Right now, a hidden ocean may be circling Jupiter in total darkness, sealed under ice so thick it has never seen a sunrise. Jupiter looks harmless from Earth, a bright pinprick that drifts across the night like it belongs to the same world as streetlights and quiet rooftops. That is the first lie the sky tells. The second lie is distance. Open any tidy diagram of the solar system and everything looks politely spaced, like a classroom poster. The truth is not polite. The truth is a wilderness of emptiness so wide that numbers stop behaving like meaning. Between here and Jupiter's realm, there is mostly nothing. No air, no sound, no landmarks, just a cold geometry where worlds travel without ever touching. And yet, out there, something keeps moving. Europa is not a planet. It is a moon, smaller than Earth's moon, pale and cracked like frozen porcelain. From far away it looks quiet, even dead. But the surface tells a different story. Long, dark lines cut across the ice like ancient scars. Plates seem to shift. Regions look shattered and refrozen, as if the world tried to break apart and then remembered how to become whole again. Those marks are not decoration. They are evidence. Because Europa lives under a constant pull, Jupiter's gravity, immense and relentless, squeezing and relaxing the moon in a slow rhythm that never ends. Like bending metal back and forth until it warms, Europa is flexed by forces so large they do not feel like forces at all. They feel like fate. That flexing creates heat, not enough to melt the surface into slush, not enough to make Europa comfortable, just enough to keep a secret from freezing solid. A global ocean, not a shallow sea, not a puddle under a glacier. A buried world of liquid water, potentially deeper than Earth's oceans, hidden beneath kilometers of ice, circulating in darkness, possibly for billions of years. If that idea makes the mind go still in the best way, tap like and subscribe. This is Nocturnal Space, stories of the universe designed for the quiet hours when curiosity is louder than the day. Now imagine what that ocean means. On Earth, life is powered by sunlight. The surface is bright, loud, full of movement. But deep in Earth's oceans, far below the reach of the sun, life survives anyway. Fed by chemistry, by heat rising from the planet's interior, by invisible reactions that turn minerals into energy. If Earth can host ecosystems that never touch sunlight, then Europa, an ocean warmed from below, sealed from the brutal vacuum above, stops being just a moon. It becomes a question. Not the small kind of question that fits in a headline, the kind that rearranges everything around it. Is life rare, an accident that happened once and never again? Or is life what matter does when water stays liquid long enough and energy keeps whispering through the dark? Europa does not answer. It only hints. And the hints are written in ice. The journey begins by admitting something that human brains resist with all their stubborn confidence. This story is not happening far away in the casual sense. It is happening across distances so large that even light takes time to cross them. Messages crawl through space with delays measured in tens of minutes. Help cannot arrive quickly. Control cannot be immediate. Anything that goes there must learn to survive alone, which is why Europa is not just a destination. It is a test of patience, engineering, and imagination. Set inside the strongest magnetic storm in the solar system, wrapped around the largest planet, spinning quietly under a sky that never turns blue. And beneath that sky, beneath that ice, the most unsettling possibility waits in silence. An ocean that has had more time than humanity has had history. Europa does not orbit Jupiter alone. It moves inside a system that behaves less like a set of moons and more like a living machine, where gravity plays the role of an engine and radiation plays the role of weather. Jupiter is not just large, it is dominant. Its mass shapes the entire neighborhood, its magnetic field stretches like an invisible continent, and its storms run on energy scales that make Earth feel delicate. In that environment, Europa is a small world doing something immense, keeping liquid water alive in the dark. The first thing to understand is why this specific moon matters more than the dozens of others. Europa sits in a narrow, unsettling sweet spot, close enough to Jupiter to be flexed and warmed by tidal forces, but not so close that it turns into Io, a volcanic inferno. Far enough to stay frozen on the outside, but not so far that its interior becomes a perfectly silent block of ice. It is balanced on a knife edge between frozen death and internal motion, and that balance may have lasted for billions of years. If there is an ocean beneath Europa's shell, it is not a temporary melt. It is a long-running world, a sealed ecosystem-sized container, a place where chemistry has had time to try the same experiment again and again until complexity either failed completely or found a way to persist. That is why Europa is not simply interesting. It is consequential. The second thing to understand is what Europa is made of, at least in the simplest, most honest description. A rocky interior, wrapped in water, wrapped in ice. A layered world, an underground sea wearing a frozen mask. The surface temperature is brutally cold, the sunlight out there is weak, and the sky above Europa offers no protection from radiation. If life exists, it would not live on the surface like an Earth creature standing under a warm sun. It would live below, where the ice becomes a roof, where water becomes a shield, where time becomes an ally. And Jupiter supplies the pressure that keeps the story from ending. Every orbit, Europa is squeezed, stretched, and kneaded like a slow heartbeat. And that motion is the reason the ocean is even plausible. But plausibility is not proof, and Europa is the kind of world that forces discipline in the imagination. The idea of an ocean is supported by patterns in the ice, by the way the surface seems to shift, by measurements that suggest something conductive beneath the crust, and by the simple logic of tidal heating acting over geological time. Still, the most honest stance is this. Europa looks like an ocean world in disguise, and the disguise is thick enough that certainty must be earned. This is where the story becomes sharper, because Europa is not only a place to wonder about life, it is also a place that shows how the solar system hides its most important environments. Humans grew up thinking habitability meant a planet at the right distance from the sun, a world with blue oceans exposed to the sky. Europa suggests a different reality. Habitable environments may be common, but buried. Not on planets, but in moons. Not under sunlight, but under ice. Not easy to photograph, but possible to infer, to test, to reach. And if that is true, then the solar system is not a neat set of dead rocks circling a star. It is a layered landscape with hidden rooms. Europa is one of those rooms. It may contain the largest accessible body of liquid water beyond Earth. It may also contain nothing but sterile chemistry. Either outcome changes what humans should expect from the universe. If Europa is lifeless despite an ocean, then liquid water alone is not enough, and life might be rarer than hope wants. If Europa hosts even simple biology, then life is not a miracle that happened once. It is a pattern the cosmos repeats when conditions hold steady long enough. That is why Europa pulls so much attention. It is not just about one moon. It is about the rule book of life itself. Europa stays warm for a reason that feels almost unfair. Not because it is close to the sun, not because it has an atmosphere that holds heat. Europa stays warm because Jupiter keeps bending it. Europa does not travel around Jupiter in a perfectly smooth circle. Its orbit is slightly stretched. That shape matters because distance controls gravity. When Europa moves a little closer, Jupiter pulls harder. When Europa moves a little farther, the pull weakens. The force rises and falls every orbit. Europa is squeezed and released again and again. That constant flexing turns motion into heat. Rock and ice inside Europa deform by tiny amounts. Those tiny amounts happen continuously for geological time. Friction builds. Energy turns into warmth. This is tidal heating. The idea is simple, but the consequences are huge. In the outer solar system, sunlight is weak. The surfaces of moons freeze into deep cold. Without an internal heat source, any buried water would eventually lock into solid ice. Tidal heating is the internal heat source that can keep liquid water alive beneath a frozen surface. Europa is not the only moon shaped by this engine. The same process operates throughout Jupiter's system. Io sits closer to Jupiter and is squeezed harder. There, tidal heating becomes extreme and drives intense volcanism. Europa sits farther out. The forces are gentler, but still strong enough to matter. Europa does not become a volcanic world. It becomes an ice world with an interior that may never fully freeze. If an ocean exists inside Europa, it is not a small hidden lake. It would be a global layer, ice on top, water beneath, rock deeper down. The exact thickness of the ice shell may vary by region, and that detail matters. A thinner shell makes exchange between surface and ocean easier. A thicker shell makes the ocean more isolated. Either way, the ocean would be sealed under darkness, protected from the vacuum above, and insulated by ice. The next question is energy. Liquid water alone does not guarantee anything. An ocean can exist and still be chemically quiet. A living environment requires usable energy. It requires chemical gradients, places where reactions want to happen, and a steady supply that does not stop. Europa has multiple plausible energy pathways. One pathway comes from below. If Europa's ocean touches rock, water can react with minerals. Those reactions can produce chemical fuels, including hydrogen, and they can create the kinds of imbalances that microbes on Earth exploit in the deep ocean. A second pathway may come from above. Europa's surface is bombarded by radiation trapped in Jupiter's magnetosphere. That radiation breaks molecules apart and creates reactive compounds. The surface becomes chemically altered over time. If the ice shell can transport some of those reactive surface products downward, then the ocean could receive chemical energy from above. That would create a powerful arrangement: chemistry from the surface, chemistry from the seafloor. An ocean that is not only wet, but active. The ice shell itself may be dynamic. Europa's surface is carved by long fractures and ridges. Some regions look disrupted and refrozen, as if the crust broke into pieces and then locked back together. Those features suggest stress and motion. They suggest the shell is not a single rigid lid everywhere. It may crack, it may shift, it may recycle material slowly over time. Even limited exchange, occurring rarely or locally, would matter for the ocean's chemistry. Europa's warmth is not a flame. It is a rhythm, a gravitational pulse that never ends. Jupiter supplies the force. The orbit supplies the timing. Europa supplies the response. Over time, that response becomes heat. Over time, heat becomes the possibility of liquid water. Europa's ocean, if it exists, would be a world made by pressure and patience. A world sealed under ice, warmed by gravity, and shaped by chemistry. A place where time is not an enemy. Time is the main ingredient. Europa stays warm for the same reason a paperclip warms when it is bent again and again. Not from fire, not from sunlight, from stress. Jupiter's gravity is not a gentle pull. It is a planet-sized grip that reaches into Europa's interior and refuses to let go. Europa does not orbit in perfect calm. Its path is slightly stretched, not perfectly circular, and that small imperfection changes everything. When Europa drifts closer to Jupiter, the pull grows stronger. When it drifts farther away, the pull relaxes. That constant change squeezes and releases Europa over and over, like a slow heartbeat that never stops. Inside the moon, rock and ice flex. Molecules rub and shift. Heat appears, not as a flash, but as a steady leak of energy. This process is called tidal heating. It is one of the most important engines in the outer solar system because it creates warmth where sunlight is weak. It turns distance into something survivable. Europa's orbit does not become perfectly circular because it is not alone. Neighboring moons keep it slightly off balance through a repeating gravitational rhythm. That rhythm prevents Europa from settling into a quiet orbit. A quiet orbit would mean less flexing. Less flexing would mean less heat. Less heat would mean an ocean that freezes solid and stays that way. You can see the same mechanism at work in Jupiter's other moons, like different settings on the same machine. Io orbits closer in, and tidal heating there becomes extreme. Its interior is kneaded so hard that it turns into fire, feeding constant volcanism. Europa sits farther out, where the same forces are gentler and more interesting. Not enough to melt the surface into a global sea. Enough to keep water liquid beneath the ice. If Europa has an ocean, it is not a small pocket. It would be a global layer wrapped around the moon. Above it lies an ice shell that could be many kilometers thick. Below it lies a rocky interior that may still supply minerals and chemical energy. Europa may be layered in a simple order. Ice above, water below, rock beneath. On Earth, oceans are open to the sky, stirred by wind, warmed by sunlight, and fed by rivers. Europa's ocean would be the opposite. No wind, no sunlight. A ceiling of ice overhead and darkness that does not end. If anything lives there, it would need energy that does not come from a star. That sounds strange until you remember the deepest parts of Earth's oceans. Sunlight cannot reach those depths, and life still survives. Around hydrothermal vents, heat and minerals rise from the seafloor. Microbes feed on chemical reactions instead of sunlight. Those microbes become the base of entire ecosystems, living in permanent night. Europa does not need to copy Earth. It only needs the same basic ingredients: liquid water, chemistry, time, and a reliable source of energy. Europa may have more than one. Tidal heating can keep water liquid. Water in contact with rock can drive chemical reactions that release energy. And Europa's surface, exposed to Jupiter's radiation, can become a factory for reactive compounds. Jupiter's radiation constantly bombards Europa's surface. It breaks molecules apart and creates oxidants, chemicals eager to react. On the surface, that radiation is hostile. It would destroy unprotected biology and degrade spacecraft electronics. But chemically, it creates potential fuel. If Europa's ice shell can move material downward, even slowly, then oxidants from the surface could be delivered toward the ocean. That would matter because an ocean with chemical energy from above and from below becomes a more convincing habitat. A place where energy gradients can persist for long periods. A place where chemistry has reasons to keep changing and where complexity might be able to hold. The ice shell is not just a lid, it is also a record. Europa's surface is cut by long fractures and ridges. Some regions look broken and refrozen, as if the crust shattered and then stitched itself back together. Those patterns suggest stress, motion, and repeated change. They hint that the shell may sometimes crack, shift, and possibly allow exchange between the surface and what lies beneath. Even without direct access to the ocean, the physics is relentless. Jupiter provides the squeeze. The orbit provides the rhythm. The moon provides the response. Over time, that response becomes heat. Over time, heat becomes possibility. Europa's ocean, if it exists, would be a world sealed under ice, warmed by gravity, and shaped by chemistry. Not bright, not easy, but stable and ancient. Ancient enough that the question stops being whether water can exist there. The real question becomes what that water has been doing in the dark for billions of years. Europa forces a brutal upgrade to the way humans think about habitability. For decades, the search for life focused on planets at the right distance from the sun. A comfortable band of warmth where oceans could sit in daylight. Europa suggests a different rule. The best environments for life may be buried, not on planets, but on moons, not under blue skies, but under ice. If Europa holds a global ocean, then it may contain more liquid water than all of Earth's oceans combined. That single fact changes the scale of the question. Europa is not a curiosity. It is a massive reservoir of possibility. But possibility is not biology. Water alone is not enough. A sterile ocean is still an ocean. The real stakes are chemical and energetic. Life needs steady energy gradients. It needs reactions that can keep running without sunlight. It needs ingredients that can cycle, concentrate, and persist. Europa's best case is an ocean that touches rock and receives chemical input from the surface. In that scenario, Europa becomes a sealed laboratory where chemistry has been running for billions of years with almost no interruption. That timescale matters. On Earth, life appeared early. The exact path remains debated, but the evidence suggests biology emerged relatively quickly once the conditions were stable. Europa has had stability in a different form: a shield of ice above, a gravitational engine below, an ocean that could have remained liquid for an absurd length of time. If life can begin in such environments, Europa is the kind of place where it might have had enough chances to succeed. If life exists there, even at the microbial level, the meaning would be enormous. It would imply that biology is not a rare accident. It would imply that when water stays liquid and energy is available, life is a natural outcome. That would not guarantee intelligent life. It would not guarantee complexity everywhere, but it would redraw the map of expectations. The universe would feel less empty in a very specific way. If Europa is lifeless, the meaning is also enormous. It would suggest that liquid water is not the main barrier. It would point to other missing pieces. Perhaps the chemistry is wrong. Perhaps the ocean is too isolated. Perhaps the energy is insufficient or poorly distributed. Perhaps the environment is stable but too quiet. A negative result at Europa would not kill the search for life. It would sharpen it. It would tell us what not to assume. The challenge is reaching the truth without letting imagination outrun engineering. Europa is difficult in ways that are not obvious from its calm appearance. Jupiter surrounds it with one of the harshest radiation environments in the solar system. High-energy particles tear through space, damaging electronics, degrading materials, and building risk into every mission plan. A spacecraft can survive there, but it must be designed like a machine meant to endure a storm it cannot see. Communication is another constraint. Europa is far enough that signals take a long time to travel. Commands do not arrive instantly. Data does not return instantly. A spacecraft cannot be driven like a remote control vehicle. It must be able to protect itself, think through problems, and execute sequences without real-time human help. Then there is the ice. The ocean is hidden behind a barrier that is both the reason the ocean might be stable and the reason it is hard to explore. Drilling through kilometers of ice is beyond current practical capability for an interplanetary mission. That is why the most realistic near-term strategy is indirect. Map the ice shell. Measure thickness. Identify the most active regions. Search for any sign of exchange between ocean and surface. Look for plumes. Look for cracks that behave like breathing seams. Plumes matter because they change everything. If Europa ever vents water or icy particles into space, then the ocean can be sampled without drilling. A spacecraft could fly through that material and analyze its chemistry. It could search for salts, organics, and patterns that suggest biology. This is one of the cleanest ways to test the ocean hypothesis and the life hypothesis with current technology. Working theory. If Europa has an ocean, and if that ocean touches rock, and if oxidants from the surface can reach the water, then Europa could support a biosphere that resembles Earth's deep ocean ecosystems more than anything on the surface. The organisms, if they exist, would not need sunlight. They would use chemical energy. They would live in darkness. They would be shaped by pressure, cold, and time. This is plausible. It is not confirmed. The stakes reach beyond Europa itself. If Europa is an ocean world with potential habitability, then other icy moons become more interesting immediately. Ganymede, Callisto, Enceladus, Titan. The solar system begins to look like a network of hidden oceans rather than a set of dead rocks. If those oceans are common, then life may have more homes than humans ever expected. Europa is also a test of human patience. The distances are large. The missions are slow. The engineering timelines are long. The payoff, if it comes, will arrive as data packets, as spectra, as faint measurements that must be interpreted carefully. And yet, those faint measurements could answer one of the oldest questions humans carry. Is life a cosmic habit or a solitary exception? Europa may not answer with a voice. It may answer with chemistry. It may answer with silence. Either way, the answer would be real. Europa hangs in the darkness like a quiet promise that refuses to explain itself. A small moon in the shadow of a giant planet, wrapped in ice, surrounded by invisible radiation, carrying a secret that cannot be seen directly from far away. From Earth, Jupiter looks close enough to feel familiar. Europa is not familiar. Europa is a reminder that the solar system is built from scale that human instincts cannot hold. Worlds can be near in the sky and unreachable in practice. Messages can take long minutes to cross the gap. Spacecraft can spend years traveling through emptiness just to arrive at the edge of an idea. And still, humans keep going. Because Europa represents a different kind of frontier. Not a landscape of mountains and valleys under a bright sun. A hidden environment, a buried ocean, a place where habitability might exist without warmth, without air, without daylight. A place where the basic conditions for life could have been stable for longer than human history by a factor that is almost impossible to feel. The most unsettling part is how normal Europa looks at first glance. Pale, smooth, quiet. And then the fractures come into focus. The ridges, the scars that look like movement frozen mid-step. The surface that seems to say that something underneath is still working. If Europa is lifeless, then the universe may demand more than water and time. The recipe for biology may be rarer than hope wants. If Europa hosts even simple life, then life is not a one-time miracle. It is what matter does when conditions persist. Either outcome changes the map. Either outcome changes the way the night sky should be interpreted. Europa is not the end of the story. It is a doorway into a larger truth. The solar system may be full of hidden rooms. Some of those rooms may contain oceans. Some of those oceans may contain chemistry running for billions of years. Some of that chemistry may have crossed the line into biology. Or it may have stayed silent forever. There is a strange comfort in that uncertainty. The universe does not rush to answer. It lets questions remain open long enough for curiosity to become discipline. It forces patience. It forces careful thinking. It forces humans to accept that knowledge is earned, not granted. Europa will keep orbiting Jupiter whether anyone looks or not. Its ocean, if it is there, will keep moving in darkness. Its ice will keep cracking and healing under the pull of gravity. The story continues even when the room goes quiet. And tonight, that is enough. A distant world with a hidden sea, reminding us that the most important places are not always the brightest. Sometimes they are sealed away, deep under ice, waiting for the moment when a small machine passes close enough to listen. If you want more journeys like this, like and subscribe.